Hello students, so we have come to the last part of our topic that we have been looking at, graphs of linear functions. So in this part we are going to be looking at applications of these linear functions. So the first application is you can use it to solve simultaneous equations, or you can use it to solve real life issues. So let's start with the first application. You are asked to solve the simultaneous equation and you are given the two equations. So firstly, when you're given the two equations, you can draw their graphs. So equation 1 is given by y is equals to, let's draw its table. Equation 1 is given by y is equals to 2x minus 1, and let's have its table. So this is y x 0 and x here 0. So when y is equals to 0, 2x minus 1, so plus 1 is equals to 2x, 2, 2x is equals to half, so put the half here. So when x is equals to 0, y is equals to minus 1, minus 1 here. So you have the table for the first equation. Let's have the table for the second equation. Equation 2, which is equal to y is equal to 8 minus x plus 5. So this is the second equation. In this table, it's given by yx 0, 0. So this is when y is equal to 0 and when x is equal to 0. So when y is equal to 0 here, so we're going to have 0 is equal to minus x plus 5. So this one we move to this side, it becomes minus 5 is equal to minus x. So x is just 5 because we divide by minus 1 here, divide by minus 1. So 5 here. Then when x is equal to 0, when x is equal to 0, y is equal to plus 5. So you're going to have y is equal to plus 5. If you put a 0 here, y is just going to be plus 5. Plus 5. So we have our two tables. So let's have our Cartesian plane. Cartesian plane is our Cartesian plane. Let's plot the first graph. So when x is half, so half is around here, y is 0. So this is our first point. When x is 0, y is minus 1. So we're going to have, this is half 1. So we're going to have point here, which is minus 1. So we now have 2 points and we can plot a graph. Remember, when you're solving for this simultaneous equation, you draw them, you must make sure that you draw them on a graph paper so that you can estimate an answer that is closer to accuracy. So for the second graph, when y is equals to 0, x is 5. So this is half, 5 is around here, 5. So when y is 5, x is 0, so y becomes 5, so it's also around this. It's 5. So you now have your 5, you have 2 points here, the point here, then you draw your graph. draw your graph. You draw your graph. So when they meet, here, that will be the solution to your simultaneous equation. That will be the solution to your simultaneous equation. So this point is true in this equation, and it's also true in this equation. If you have done this on a graph paper, you take a reading for the x and you take a reading for the y here. And that will be the solution to your simultaneous equation. So let's move to the next question, example 2. Let's move to example 2. The cost of hiring a truck is $50. So that's the cost of hiring a truck plus $10 per kilometer. So that's the fixed cost, is $50. So if I hire a truck and leave it parked at home, the cost will be $50. So I'm going to say, express this in this form: mx plus c. So if I hire a truck and do not drive it, the cost will be c. So my graph will be like this. If I hire a truck, that's $50, that's the cost. So y will represent the cost, and fixed cost, which is just the cost of hiring, which is x will represent the variable cost per kilometer. So if I just hire it, if I just hire a truck and leave it parked, my graph will be like this, and this will be $50. It will be $50. So this one will be kilometers, and that one will be money. So $50, which means my graph is going to begin with $50. That will be this will be the y-intercept. So already when I'm writing my equation, I've already found my c. And $10, that's the rate. So that's my m, the gradient. So my equation can be y is equal to 10x plus 50. This will be my equation. So I'm told to write the equation. I wrote my equation. So x will represent the kilometers. X will represent the kilometers, and y will represent the total costs, which has a fixed cost attached to it, which is $50 just for hiring. So I'm asked to draw the graph. So already I have my point here. Because you are given 2 points already for y, you need to draw your table. Remember, you have y and x. If you need to draw your table, so you are given when y is 0, and when you need to find the cost of, so you are given when x is 0. Yeah, and when x is 50, that's what you want to know. When x is 0, this one is 50, that one is 50, this point here. It's when the x coordinate is at 0. So when the x coordinate is at 50, so you have this equation. When the x coordinate is now at 50, so you have y is equals to 10 times 50 plus 50. 15 plus 50. So in order to find the y coordinate, that's going to be y 10 times 550. That's going to be the cost at 50 kilometers, which is going to be 550. So maybe if you are on a Cartesian plane, if you are on a Cartesian plane, you might plot your points. Maybe this is 550, and you know that your x-coordinate in kilometers is going to be 50. Then you plot your graph, and you have 2 points. Then you join your points with a straight line. So you join your points with a straight line. That will be simple. So that's how you solve this one. You take this point as the first point, and you take 50 kilometers as the second point. Already you have 2 points and it's a straight line. You join the 2 points. So we've come to the end of the topic, graphs of linear functions. And when we meet again,